Okay, as promised, I'm going to go through the Chapter 1 problem set number 2, which is the practice AP multiple choice questions. So I'm going to go ahead and go through this if we can. I think what I'm going to do is I'm going to do this as a student view. Remember that this was in the quizzes, so if you have not completed this and you don't have a grade for it, it is in the quizzes, okay? All right, so here's number 1, when each of the following is heated to 50 degrees and the temperature is held constant for 5 minutes, which one undergoes only a physical change? The answer to that is ice cream. All right, and the reason for that is because the ice cream would melt. So that is C. Okay. Egg is going to change chemically. So when you cook egg, if you cook anything, if it cooks into something else, then it's a chemical change. Steak changes its chemical composition. The steak caramelizes and caramelizes the sugar, and so the tasty steak that you get when it's done has been chemically changed. Same thing with a cake. When a cake is cooked, the sugar in the cake batter crystallizes. Okay, and then you also have rising, and that rising is making CO2. That CO2 gas expanding, pushing on the dough, causes the cake and the cookies to rise. And that's a chemical reaction because you're making CO2. Number 2, we did this one in class. We're looking at the densities here. So if you look at the densities, that's 1 liquid because they're about the same. That's 2 liquids. That's 3 liquids. Same thing here. Look, 1 liquid, 2 liquids, 3 liquids. 1 liquid, 2 liquids, 3 liquids. So we can kind of see how these numbers are the same. So this is 1 liquid, this is another liquid, and this is another liquid. So there are 3 liquids there. 4 different kinds of inks are placed on chromatography paper, and a solvent is introduced and allowed to move up the paper. Okay, so imagine that this is ink, and the ink is going to spread, and this is as far as it gets. So 4 different compounds are going to produce these ink spots. So this is the start, this is the finish. From the diagram shown above, which 2 inks are likely to contain molecules that have the most similar molecular structures? So what we can do here is look at these guys. So this one has a dot here only. This one has 2 dots way up here, a very, very fast molecule. This is the smallest molecule because it's moved the farthest. The smallest molecules move the farthest. This guy has 2 dots here, and this guy has a dot here. Okay, so which 2 of these 4 compounds are most similar? Okay, and it'd be these 2, A and D. These are pretty close to each other, right? It's not that far off, and so these are probably the same thing, or they have very similar structures, right? They reacted on the paper the same to produce a dot almost in the same place. These guys have 2 dots way up here. That's quite a bit of difference here, and then these 2 are very different, and then these 2 are very different. So these 2 have dots in the same relative place, and so they're likely the same compound. So A and D. All right, 4 different inks are placed on chromatography paper, and a solvent is introduced and allowed to move up the paper. From the diagram shown above, which ink contains a component likely to have a molecular structure most similar to that of the solvent? Let's see. Incorrect. Most likely to the solvent. Solvent is introduced. 4 different inks are placed on chromatography paper, and a solvent is introduced and allowed to move up the paper. From the diagram, which ink contains a component? This one I'm not sure off the top of my head. Maybe I can look at my answer key somewhere. Let's leave student view. Maybe I can look at my answer key. Let's do edit. Questions. This question is number 4, right? Yes, number 4. What is your answer, number 4? Let's edit that. Correct answer is B. So let's look at that. All right, 1 second. Correct answer is B. I got to go back to student view so that I can open it and view it like a student. Quizzes. So number 4 is B. Okay. I'm thinking that, okay. So if you look at B, this one moved the farthest. And so if it moved the farthest, it's very similar to the solvent. Okay, because the solvent moves. So what we did is we started it here, and the solvent allowed them to spread. And so since this one went the farthest, it's the closest to the solvent. So it dissolved with the solvent and moved with it, right? Whereas these guys reacted differently to the solvent and moved slower. So this guy moved the farthest, so that would be closest to the solvent. All right, so whichever one moves farthest is the most similar to the solvent, which is the thing that does the spreading. So if you did the chromatography paper with just ink and let the ink spread and watch the ink spread, water would be the solvent. Okay. Okay. Number 5. 4 substances with the following structures are placed on chromatography paper with water as a mobile phase. The paper is allowed to touch the water. After an hour, which substance will have moved the farthest on the paper? Water consists of HOH molecules. So let's have a look at this one. Again, I'm not sure off the top of my head, so we will go in and look at the answer key. Okay, this is number 5, and the correct answer to number 5 survey says A. Okay, so let's have a look. A. Oh, okay. So look at this molecule. HOH. Y'all see the OH right there? Look at that. OH on the outside of the molecule. So that's very similar to the water molecule. It's got the same exact formula right there. I'm trying to think of the name of that. Functional unit, I think is what it would be called. Functional group. It has that OH group right there. So that's the same. These other molecules have O and H, but they're in different places. So this is 2 carbons attached to an oxygen. We don't see that with water. And then the hydrogens are attached to the carbon. Not here, right? Oxygen and hydrogen are attached. So oxygen and hydrogen are attached. Not so here, not so here, not so here. Here we got carbon double bonded to oxygen. So we don't see that OH molecule, right? That OH bond in these guys. So these two will be more similar because of that right there. That's called a hydroxide group, or what do they call it? They call it an alcohol group. So this actually right here is ethanol. This is ethanol. This is an ether. I think this is ethyl ether. This is propanol, which is a ketone. This is or propanol maybe, and then this is ethane. All right, number 6. We did this one in class. Trying to remember what the answer to this one is. Number 6. Before, during, and after. I'm trying to remember this one. It's a mixture before, during, and after. I don't remember this one. So let's have a look. Number 6. Correct answer is B. Okay. This is a compound. A 100 milliliter graduated cylinder is filled with a 100 liter mark. A few drops of food coloring are added to the top of the water without mixing. Initially, the top of the graduated cylinder appears to be very dark, while the bottom remains clear and colorless. After 5 minutes, the liquid in the graduated cylinder appears to be uniformly colored. Oh, okay. So after it's done, it mixes and everything's good. So did we say compound here? Correct answer is compound. So I'm trying to think of the reasoning of this. We mixed it with water. This is water. And then we added food coloring right here. Oh, and then the food coloring just separated. And so if the food coloring mixes perfectly with the water, then it's just water. Before, Yeah, so if it just mixes with that liquid, then it's just a compound. Yeah. All right, number 7. Classify the contents in the graduated cylinder just after the food coloring is added. That one is C. So it was a heterogeneous mixture when it looked like this, right? If you look at this one, you see the blue and the green, they're different. Remember that that's a heterogeneous mixture. 2 different phases that are visibly distinct from one another. Different colors separated. So 2 liquids separated. If they were mixed uniformly, then we could call it a compound or a homogeneous mixture, which would be a solution. All right. Classify the contents in the graduated cylinder after the 5 minutes have elapsed. So this one will be D, a homogeneous mixture. So we took food coloring, we took this liquid, we mixed it, it made a solution where it's green throughout and the green's perfectly mixed. It's not all, it's not 2 layers or anything, so it's all one thing. So that's a homogeneous mixture. Okay, kind of like salt water. You take salt, you put it in water, and it mixes well. And so it's one thing, and it's uniformly distributed. So that's a homogeneous mixture. Okay, number 9, I'm just going to give you guys the answer. Number 9 is D. Okay, several of Jupiter's moons are believed to have liquid layer, possibly water, below their icy surfaces. NASA and the European Space Agency are planning several probes that will visit the moons of Jupiter. It has been suggested that a probe could land on the moons and drill through the surface of ice to the liquid layer. The probe would then sample the liquid at 5 different depths. Why will the probe test the liquid at 5 different depths? And that is to determine whether the liquid layer is a homogeneous solution or a heterogeneous mixture. So if we drill at different depths, we can see if it's still just one layer or if there's different layers lower. So maybe lower in the surface, maybe there's different substances buried there. So we might find water ice buried there. And if we find water ice, then we might find life. So that's kind of cool. Number 10 is B. A 10-gram piece of metal is submerged in the graduated cylinder. It has 20 milliliters of water with the metal in the cylinder. The level of the water is recorded to 21.40 milliliters. Determine the identity of the metal. All right, so we got 10 grams, and let's see, we got 20 milliliters of water. So we take a 10-gram piece of metal and we put it in water that's 20, and then the water level is recorded to 21.4, so it goes up by 1.4 milliliters. So we're going to do, see if y'all can see my calculator here. So we're going to do 10 grams, which is the mass. We're going to divide it by the volume difference, because the volume difference here is the volume of that metal. So that's going to be 1.4. So 10 divided by 1.4. And we get 7.14. So that's why it's B. Right? We said B? Yeah. So, yeah. So there we go. That's 10. Whew, that was a lot. All right. Awesome. Last thing is let's look at the NMSI notes real quick. So if we go back to courses and look at the NMSI notes. They are in here somewhere. NMSI notes number 3 right here. So if we click this link here, it opens this. I've got my general expectations here. I leave that in there so that you guys kind of know what I'm expecting. And then here's the specifics for this homework. This is the part 1 of chapter 3 on stoichiometry. Here's the link to the video. Here's the password. I think you're going to be asked a password. So it's Linus Pauling, all lowercase. And then here's a PDF copy of the notes. And then this is what I need you guys to copy down. Okay. And then submit that on Canvas or email it to me. I'm fine either way. Just know that if you don't submit it on Canvas, it will mark it as missing, which is kind of annoying. So if it does that and you emailed it to me, just get on the assignment on Canvas and write done or emailed to teacher or something like that, and then it'll mark it as done if you write something in that submission box and submit it. Okay, but until you submit it, it'll say it's not submitted. Then let's look at the homework problem set number 2 from chapter 2. Where are you? Chapter 2, problem set number 1. This is due the 14th. So if we click on this, let's have a look. Let's look at this one. So the following data were collected for several compounds of nitrogen and oxygen. I want you guys to show how this illustrates the law of multiple proportions. So this is very similar to what we did in the video. So if you need to, go back to the video or go back to the NMSI Notes, and you can see that. Write the symbol for the atom that has atomic number 9 and a mass number of 19. So we talked a lot about how to write the chemical configuration for an element. All right, so that one shouldn't be too bad. Which of the following combinations of elements is likely to produce an ionic bond? That's going to be one where it's a metal and a non-metal. So try to find one where it's a metal and a non-metal, and they will form an ionic bond. The diagram shown above best represents which of the following. So we've got this guy, and then it's got this, which is the belly. We've got the 3 dots, then we got the head here. So notice, here's the hint to this one. Everything that we have here is still over here. It's just rearranged. All right, so that's one of our conservation laws. Okay. This one, another conservation question. So go ahead and try these as best you can. I'm trying to give some hints, but not really much I can give away here. Which of the following equations satisfies the law of conservation of mass? So look at the balancing of these equations and make sure you have the same number of atoms on both sides. And maybe same thing here. Look at the atoms and make sure that you have the same number of atoms on both sides. Make sure that this picture represents this. So hydrogen here is the white small balls, and then the red is the oxygen, the larger circles. Okay, so white is hydrogen, red is oxygen. And look how it's arranged in the equation. Just match it. That's not too bad. Take a look at this one. See if these will divide it into each other, and you can see which law. But that's law of multiple proportions. Here's another tricky one. This one is a conservation question. So look at this reaction and look at your masses before and after, and just know that the masses need to be the same. Okay, before and after. This one's isotopes. Remember that an isotope is a different version of an element. So there are different isotopes of oxygen, but they're still oxygen. So it doesn't involve charges, and it doesn't involve changing elements. It needs to be the same element, just different mass number. Okay, and that's it. All right, so this video is done. Awesome.